Okay, so additional example for fluid mechanics. A wooden pole with a specific gravity of 0.55, 550 millimeters in diameter, has a concrete cylinder S or with a specific gravity of 2.5, 550 millimeters long, and the same diameter attached to one end. A unit weight of water is 9.79 kilonewtons per cubic meter. So number 1, what is the minimum length of pole for the system to float vertically in static equilibrium? So parang ito yung magiging illustration natin sa problem. Yung diameter ng wood, tapos yung diameter ng concrete cylinder, sinabi ko na lang dito, diameter of the stone, pareho sila ng diameter, 550 millimeters, or sabihin natin in meter, that is 0.55 meter. So specific gravity of the wood, 0.55, for the stone, 2.5. Given naman yung length ng stone, 550 millimeters din. So, always start with mechanics. Ano yung mga forces na involved? Una, we have the weight of the wood. Sabihin ko na lang weight number 1. Then, pangalawa, that is the weight of the stone, weight number 2. Okay, kung ilang object yung exposed sa tubig or sa liquid, yun yung number of buoyant force. So we have buoyant force number 1. Ito yung para sa kahoy. Then let's say this is the buoyant force number 2. Ito naman yung para dito sa stone. So since kompleto naman yung dimension ng stone, given yung kanyang length, ay alam natin yung kanyang specific gravity, given rin yung kanyang diameter, pwede nating i-compute yung weight ng stone. So, paano ba mag-compute ng weight? So, standard natin, gamma, or the weight is basically equal to gamma times the volume. So, we have, this is weight number 2, weight ng stone, gamma. Specific gravity ng stone is 2.5, na given dito. Yung given na gamma water dito, yun yung gamitin natin, 9.79 kilonewtons per cubic meter. Ano yung volume ng stone? The same diameter with the wood, 0.55 squared pi. This is divided by 4. Tapos yung length niya, 550 millimeters. So, pareho lang, 0.55 meter. So, this will be the weight of the stone. Okay, that is 2.5. So, yung given na gamma water dito, yun yung gagamitin natin, 9.79.55 squared sheep pi. This is divided by 4. Then multiplied by 0.55. Okay, that is, let's say, 3.198 kilonewtons. So, hinahanap natin sa number 1 yung length ng wood para maging ganito yung setup. So, sabi niya, okay, lulutang yung wood. The minimum length for the pole system to float vertically in static equilibrium. So, ang gagawin natin ay dapat lulutang yung setup na to. Okay, so by mechanics, this is summation of forces, vertical equal to 0, assuming upward forces to be positive. This is for number 1. So, by the way, ano equivalent ng buoyant force? So, basically, buoyant force is equal to gamma, liquid, then the volume, submerged. Okay, so, for equilibrium, ano yung mga pataas? Yun yung buoyant force number 1, that is against the wood, plus, this is the buoyant force number 2, that is against the stone. Okay, ano naman yung mga pababa? Weight number 1, yung weight ng wood, plus yung weight ng stone, weight number 2. So, mag-substitute na tayo. So, buoyant force number 1, ay i-consider natin yung total volume ng wood in terms of L, yung length. So, gamma water, yung given dito is 9.79. Ayun yung gagamitin natin. Yung volume ng wood, diameter is 0.55 squared pi. This is divided by 4. So, the length, yun yung required in terms of L. So, this will be the volume of the wood. Area times the length. Then, plus, buoyant force number 2, that is against the stone, ay 9.79 times Okay, the volume of the stone, alam din natin yun kasi given yung length, given yung diameter. 0.55 squared pi, this is divided by 4, multiplied by the length, 0.55 meter, or yun yung 550 millimeters, is equal to the weight of the wood. So, ano ba yung specific gravity ng wood? 0.55. So, gamma, that is 0.55. Gamma water is 9.81 sana kung hindi given. Pero yung given is 9.79. Yung volume ng wood is 0.55 squared pi. This is divided by 4 multiplied by the length. Yun nga, dahil hindi pa natin alam yung length. Tapos yung weight number 2, that is the weight of the stone. Na-compute na natin yun kanina. That is 3.198 kilonewtons. So, plus 3.198 kilonewtons. So, in this equation, as you can see, ang unknown na lang is yung the length of the wood. So, compute natin. That is 9.79 gamma volume, 0.55 squared. This is sheep pi divided by 4 multiplied by alpha x na lang muna sa ngayon. Then plus 9.79, that is multiplied by 0.55 squared sheep pi divided by 4. Then to be multiplied by the length of the stone or the concrete cylinder, 0.55. Is equal to yung weight ng wood, gamma volume, 0.55 times 9.79, then multiplied by the volume of the wood, 0.55 squared, sheep pi, this is divided by 4 in terms of the length. So, alpha x. Then plus the weight of the concrete cylinder, 3.198. So, shift solve tayo. That is 1.833. So, the length is now equal to 1.833 meters. So, let us check kung meron ito sa choices for question number 1. So, the minimum length of the pole, that will be equal to letter A. So, 1.833. Okay, question number 2, compute the weight of the wood. Yung weight ng wood na portion, ito lang yun kanina, yung equation na to. Ito yung weight number 1 natin kanina. So, isa-substitute lang natin dyan yung length. So, this is for number 2. Ito yung weight number 1 natin kanina, which is the weight of the wood. Okay, so standard, that is gamma volume. So, gamma, 0.555 times gamma water, 9.79 for this example. Okay, multiplied by 0.55 squared, sheep pi over 4. Then, yung computed length natin, 1.833 meters. So this will be weight number 1 or the weight of the wood. That is 0.55 gamma water, 9.79. This is 0.55 squared, sobra. Squared sheep pi, this is divided by 4. Computed length is 1.833. So shift solve. Bakit tayo nag-shift solve doon? Wala tayong variable. That is 2.345. 2.345 kilonewtons. So, ito lang naman yung required number 2. So, check natin sa choices. Closest value, 2.345. That will be letter D tayo. 2.34. The number 3, the total weight of the wood and the concrete. So, the total weight of the concrete cylinder and the wood, dali na lang yun. So, weight total is weight number 1 plus weight number 2. Weight number 1, ito lang yun, yung kakuha natin, 2.345 plus, yung nakuha natin kanina, weight number 2, the weight of the concrete cylinder. That is 3.198. 3.198. So, that is 2.34. Okay, gamitin ko na yung stored value na yan. Plus ay 3.198 kilonewtons. This 5.543. Okay, so weight total is equal to 5.543 kilonewtons. So let us check if we have this value sa choices sa question number 3. So 5.543, so closest value natin will be letter D, 5.54. So this will be our solution for problem 1, 2, 3. Okay, tuloy natin sa problem 4, 2, 6. A barge along Pasig River is in the form of a parallel pipe having dimensions 30 meters long, 10 meters wide, and 3 meters high. When loaded, has a total weight of 4,500 kilonewtons and the center of gravity is 4 meters above the bottom of the barge. The liquid of the river has a specific gravity of 1.01. So number 4, compute the draft of the barge. So yung dimension natin, 30 by 10 meters. Then yung total height niya is 3 meters. So nabanggit na yung center of gravity is 4 meters from the bottom of the barge. So medyo kakaiba yon dahil 3 meters yung height pero 4 meters yung location ng center of gravity. Pero basically, dahil na rin siguro yun dun sa nabanggit naman niya due to load. So hinahanap natin dito yung draft. Sa stability of floating bodies, the term is draft. Pero kapag ordinary buoyancy problem, yun yung ating height submerged. Yung depth lang na nakalubog. So by mechanics, so pwede nating simulan ito ng mechanics lang. Okay, so i-consider natin ano yung weight ng barge plus the load. So given din ito, the total weight is equal to 4,500 kilonewtons. So since lulutang ito, that will be, kukontrahin yun ng buoyant, the buoyant force. So by summation of forces vertical equals 0, this is for question number 4. So summation of forces vertical equals 0, assuming upward forces to be positive, yung buoyant force is simply equal to the weight, and the weight or the weight total is equal to 4,500 kilonewtons. Yun lang naman yung dalawang forces na i-consider natin. Ay, paano tayo magko-compute ng buoyant force? That is the gamma liquid, then volume submerged. So, i-assume lang natin na yung height submerged is the D. So, substitution, this is the gamma liquid, then volume submerged is equal to 4,500 kilonewtons. So, yung gamma ng liquid na to, nagbigay siya ng specific gravity na, that is for problem number 4. Specific gravity ng tubig this time is 1.01. So, this is 1.01. 1.01 times gamma water. Gamitin natin yung 9.81 dahil wala namang ibang given. Yung volume na nakalubog is, ulitin lang natin, yung dimension ng barge ay 30 meters by 10 meters. So, yung area is 30 times 10 times the volume na nakalubog, volume submerged, D. That is the draft. Then that is equal to 4,500 kilonewtons. So, compute natin what will be the draft or the height submerged. That is 4,500 divided by 1.09 times 9.81. Okay, then multiplied by the area. That is the 30 times 10. 1.5139. So, sabihin natin 1.514 meters. So, that will be the height submerged or the draft. Okay, check natin if we have this value sa question number 4. So, that will be letter C, 1.514 meters. Okay, question number 5. What is the metacentric height with respect to rolling? So, paano ba tayo nagko-compute ng metacentric height? So, i-recall lang natin yung basic natin sa metacentric height. Ito yung mg Okay, for the metacentric height, that is yung mg equal to, okay, the b sub o minus, okay, the gb sub o. So, ano yung mga points na yon? So, ilagay lang natin para maging ano lang. Ilagay lang natin yung mga points na kakailanganin natin dito. So, for stability of floating bodies, i-assume natin na pag stable yung isang floating body, kailangan yung metacenter, yung M, is above the center of gravity. So, again, ito yung mg, the metacentric height. So, ito yung hinahanap natin. Ano yung distance na yan? From the metacenter to the center of gravity. Pero, kailangan muna natin i-compute yung the distance from the metacenter M to the center of buoyancy. Yung center of buoyancy is the B sub O. So, ito yung distance na yon. Okay, that is, okay, from the metacenter to the center of buoyancy, M, B sub O. Para makuha yan, kailangan natin yung distance na to. From the center of gravity, that is the center of gravity, papunta sa center of buoyancy. Ito naman yung the center of gravity to the center of buoyancy, the GB sub O. So, paano ba natin kukunin or ilolocate yung center of buoyancy? Di ba may na-compute na tayo dito na depth submerged or the draft? Ang na-compute natin na draft kanina dito is 1.514. Yun yung required sa number 4. So, kung ilolocate lang natin yan, yung center of buoyancy mula sa ilalim, kalahati lang yan ng value na yan. Kalahati nung nilubog na height. So, that is 1.514 divided by 2. That is equal to 0.757. 0.757 meters. So, yung location ng center of buoyancy is 0.757 meters from the bottom of the barge. So, alam natin yung location ng center of gravity from the bottom of the barge. That is 4 meters. So, para makuha natin ay yung value ng GB sub O, that is basically equal to, yung 4 meters na to, 4 meters minus yung kalahati ng draft, the D over 2. That is equal to 4 minus 1.514, okay, divided by 2. Ito yung distance from the center of gravity to the center of buoyancy. So that is 4 minus 0.757. That is, okay, 3.243 meters. So that will be the GB sub O. Okay, paano naman tayo nagko-compute ng MB sub O? The distance from the metacenter to the center of buoyancy. So, pwede ito by formula. Kung rectangular yung section, okay, so we have the formula that is yung M, B sub O is equal to the B squared, okay, divided by 12 times the draft, okay, multiplied by 1 plus, okay, the tangent squared of theta, this is divided by 2. Kaya lang sa problem na to, I think sa number 5 tsaka number 6, or pati na sa mismong problem, wala naman siyang binanggit regarding sa rotation. Kung walang nabanggit na rotation, we assume the value of theta to be 0 degree. Okay? So, walang nabanggit na rotation, then the value of theta is equal to 0 degree. So, kung 0 yan, ang mangyayari lang dito, tangent of 0 is 0. So, kung theta is equal to 0, ang equivalent lang ng M B sub O is simply equal to the B squared divided by 12 times the draft. Okay, nakuha na natin yung draft kanina. Ito yung 1.514 meters. Okay, so binanggit niya class sa number 5 na hinahanap natin yung metacentric height with respect to rolling. Kapag sinabing rolling, i-consider natin dito yung weaker axis. Yung weaker axis ng floating body. So, yung weaker axis is, along the weaker axis, yung shorter dimension. Diba? 30 meters long, 10 meters wide. I-assume lang natin na yung B will be the weaker axis, the shorter dimension. Ito yung 10 meters. Para dun sa formula ng B sub O. Okay, dito? So, ito yung sinasabi niya na rolling. Yung pag-rotate ng floating body, okay, along the shorter axis. So, this is, okay, the term is rolling. So, kapag rolling, the value of B should be equal to 10 meters. Okay, kunin natin. This is now the B sub O. With respect to rolling, it is B equal to 10 meters squared divided by 12 times yung nakuha natin na draft, 1.514 meters. Okay, kunin natin yung distance from the metacenter to the center of buoyancy. Okay, that is 10 squared divided by 12 times 1.514 meters. That is 5.504. So, ang hinahanap natin is the metacentric height mg. Ito yung metacenter to the center of buoyancy minus the center of gravity to the center of buoyancy. So, balikan lang natin ulit yung figure. So, di ba, ito yung nakuha natin na distance from MB sub O. That is yung metacenter to the center of buoyancy, MB sub O. Ibawas lang natin yung GB sub O. Yun na yung mg. Or ulitin lang natin siguro para mas malinaw. Okay, ito lang yung mga points na i-consider natin. So, di ba, we have the metacenter M, the center of gravity G, the center of buoyancy. Kung gusto nating i-compute yung mg at meron ka ng value ng MB sub O, kailangan mo lang ibawas yung distance na GB sub O. So, we have now the mg. Okay, the metacentric height mg is equal to MB sub O. Ang na-compute natin is, using this equation, MB sub O is 5.504 minus yung GB sub O kanina. Saan na pala yung value ng GB sub O? The GB sub O, ito yan. So, 3.243 meters. Okay, so we have the metacentric height mg for question number 5. Ito yung 5.504 minus 3.243. So, let's say that is 2.261 meters. So, check natin if we have this value sa choices. 2.261. Okay, this is question number 5. Okay, 2.261. That will be letter A. Number 6. Determine the metacentric height with respect to pitching. Okay, kapag ginamit naman yung term na pitching, doon tayo sa stronger axis, yung longer dimension. So, i-assume lang natin na yung value ng B this time will be yung longer dimension. Okay, the 30 meters. So, paano naman yung direction ng pitching? Ito yung pag-rotate ng floating body along its longer dimension or the stronger axis. Ito yung, that is the pitching. Okay? So, hanapin natin yung value ng metacentric height niya. So, again, kung pitching, i-consider lang natin na yung value ng B will be the longer dimension. That is 30 meters. So, nagbago lang tayo ng orientation doon sa floating object. Nandito lang pa rin yung center of gravity. Nandito pa rin yung center of buoyancy. Ito pa rin yung distance natin kanina na the GB sub O equal to, ano yung value na yun? 3.24, 3 meters. This is 3.243 meters. So, nandito lang ulit yung ating metacenter. So, kunin lang ulit natin yung the MB sub O. From the metacenter to the center of buoyancy. So, again, we have the draft is equal to 1.514 And theta natin dito is pareho lang naman. Wala naman siyang binanggit na rotation. So, we have the value of theta is the same as 0 degree. Pareho lang dun. So, magiging ang equivalent lang ng mb sub o will be equal to the b squared divided by 12 times the draft. Okay, this is for question number 6. So, this is equal to 30. We have 30 squared divided by 12 times 1.514. And that is equal to ito ba yun? So, 49.538, medyo mataas. Okay, 49.538 meters. So, mas mataas ito. Dahil mas maliit kasi yung chance na mangyari yung pitching. Mas maliit yung chance na mangyari yung pitching compare sa rolling. Okay, that is, okay, mb sub o is 49.538 meters. So again, we have mg is now equal to the b sub o minus the gb sub o. So this is equal to 49.538 meters minus, ano ulit yung value ng the gb sub o? This is equal to 3.243 meters. So the metacentric height instead in terms of the pitching is 49.538 minus 3.243. So this is equal to 46.295. So 46.295 meters. So check natin if we have this value sa choices. Question number 6. 46.295. Okay, so we have that as letter D tayo. 46.295 meters. So this will be our solution. Okay, for question 4 to 6. Okay, problem number 7 to 9. A vertical circular gate 0.90 meter in diameter is subjected to pressure of liquid with specific gravity 1.5 on one side. The free surface of the liquid is 2.4 meters above the top of the gate. Okay, question number 7. Evaluate the total force on the gate. So ito yung illustration natin. So basically, how do we compute for the force, number 7, for submerged surfaces? Ito yung, that is the gamma h bar times the area. Okay, so ang kailangan lang natin gawin dito is locate the center of gravity of the circular gate. So this is CG. So pwede natin sabihin that the h bar from the liquid surface, since wala naman siyang binanggit na pressure sa liquid surface, ito yung the h bar. So the equivalent ng h bar or bar h dyan is yung given na 2.4 meters. This is 2.4 meters plus diameter is 0.9. So that is 0.9 divided by 2, the radius. So we have that as we have 2.4 plus 0.9 over 2, or that is simply 0.45. This is 2.85. So h bar is equal to 2.85 meters. Okay, so the specific gravity of the liquid is 1.5. So we have now the force is gamma. Specific gravity ng liquid is 1.5. Gamitin natin yung 9.81. So, h bar is 2.85 meters. Area in terms of the diameter, 0.9 squared pi, this is divided by 4. So, computing for the force, that is 1.5 times gamma water. Gamitin natin ito dahil wala namang given. Multiplied by 2.85. Then area, 0.9 squared, shift pi over 4 in terms of the diameter. Is 26.6796. So sabihin natin 26.68 kilo Newton. So check natin if we have this value sa question number 7. Okay, letter C tayo, that is 26.68. Okay, number 8. Locate the point of action of the total force from the bottom of the plate. So, alam natin na yung point of action ng total force is on the center of pressure. Okay, so ito yung center of gravity. Yung center of pressure is below the center of gravity. So, nandito yung point of action. Okay, the point of action of the total force. That is at a distance E. Okay, at a distance E from the center of gravity. So, kailangan lang natin kunin yung eccentricity. Okay, that is for question number 8. So, paano ba tayo nagko-compute ng eccentricity for vertical gates? E is equal to, this is the moment of inertia, okay, divided by the area times the h bar. Ano yung moment of inertia kapag circular section? Kapag in terms of the diameter, ito yung pi d raised to 4 divided by 64. Okay? So, kunin natin yung eccentricity. Pero yung required pala dito is yung distance daw ng point of action ng force mula dito sa ilalim. So, ilagay ko na lang siya as distance z. So, di ba alam natin na mula sa center of gravity papunta dito sa ilalim, ay sa ilalim ng gate is basically equal to the radius. Ano ba yung radius nito? 0.9 yung diameter. So, the radius is 0.45 meter. So, basically, yung equation na relation nung tatlo, that is yung radius ay equal dun sa eccentricity plus yung required na z. Okay? So, kunin muna natin yung eccentricity. Okay, this is the eccentricity is moment of inertia, pi, diameter, 0.9 raised to 4. This is divided by 64. Okay, divided by area in terms of the diameter, pi of 0.9 squared. Okay, divided by 4. Then, h bar, ano yung h bar kanina, or bar h? That is 2.85. So, we'll be having the value of the eccentricity. Okay, that is shift pi. Okay, 0.9 raised to 4. This is divided by raised to 4 divided by 64 all over area. That is shift pi of 0.9 squared. This is divided by 4. And then multiplied by the h bar, this is 2.85 meters. Equal to 0.0, gawin natin 3 decimal, 0.018 meter. Okay? So, yun yung eccentricity. So, again, kung iano natin, yung point of action ng force ay nasa center of pressure at a distance E from the center of gravity. Ang hinahanap kasi natin dito is yung distance ng force ay from the bottom of the gate, yun yung distance z. So, z plus e is basically equal to the radius na 0.45. So, computing now for the distance z, that is r is equal to yung z plus e. The radius of the gate is 0.45 equal to z plus yung e na na-compute natin, 0.018 meter. So, we have the value of z is now equal to, that is 0.45 minus 0.018. That is 0.432. 0.432 meter. Check natin ito sa question number 8. Okay, so 0.432, that will be letter A tayo. Sa number 9, if the gate is hinged at the top, compute the normal force to the gate at the bottom that will be required to open it. So parang ganito yung mangyayari. Okay, mag-apply tayo ng force dito sa ilalim. So let's say yung ilalim na lang is point B, yung taas is point A. Naka-hinge daw dito sa point A. So let's say this is the force at B. So alam natin na ito yung point of action of the force at a distance of, di ba, ito yung eccentricity. This is the distance, eccentricity. Ito naman yung radius. Yun yung location naman nung total force acting on the gate. So hinahanap lang natin yung F sub B. So, pwede tayong mag-moment dyan sa A for question number 9. So, sa number 9, so summation moment at A equal to 0, assuming clockwise moments to be positive. So, that will be yung force, ang lever arm, gaano kalayo yung force na to from A? Yun yung radius plus the eccentricity. Okay, the radius plus the eccentricity. Then minus yung force sa bottom of the gate, that is the F sub B times, gaano yun kalayo from point A? Obviously, that is the diameter of the gate. Okay, times 0.9 equal to 0. So mag-substitute na tayo. The force is 26.68. Ay, tama ba yan? Yes, it's 26.68 kilonewtons. The radius of the gate is 0.45. Eccentricity kanina is 0.018. Ay, minus. So, tama ba yung E? Eccentricity is 0.018. Ay, minus. Ay, the force at the bottom of the gate, F sub B, this is multiplied by 0.9 equal to 0. So, we have the F sub B is now equal to, ito yung 26.68 times 0.45 plus the eccentricity, 0.018. Ito be divided by 0.9. It's 13.874. 13.874 kilonewtons. So, check natin yung value na to sa question number 9 if we have that value. Okay, so that will be letter D, 13.87. So this will be our solution for problem 7 to 9. Okay, problem number 10 to 12. A water tank has a sloping side inclined at 45 degrees with the horizontal. The total depth of water is 6.7 meters. A water jet issues from an orifice located on the inclined side under a head of 4 meters. Okay, coefficient of velocity equal to 1. Number 10, compute the maximum height of the issuing jet arises above the center of the orifice. So parang ito yung illustration natin para dito sa problem na to. Okay, we have required dun sa number 10 is tinatanong yung Hmax. Yung maximum height nitong tubig ay above the center of the orifice. So, lagay lang natin siya as, or Ymax na lang. Ay, Ymax. Okay, yung pinanggagalingan ng tubig is naka-incline na 45 degrees. Yun na rin yung magiging inclination ng water jet. So, this is the same as 45 degrees. So, coefficient of velocity is equal to 1. Okay, nagbigay siya ng coefficient velocity, basically para makompute yung actual velocity. Okay, paano ba tayo nagko-compute ng actual velocity? Ito yung coefficient of velocity, the square root of 2g, 2g times the h, or the head. So, actual velocity is equal to 1, okay, multiplied by twice of 9.81, ay under a head of 4 meters. So, ano yung actual velocity nito? 1 lang naman yun. So, 2 times 9.81 times 4. 8.85889. So, sabihin natin, this is 8.859 meters per second. So, 8.859. Okay. So, paano tayo nagko-compute ng Hmax? Di ba sa P6, yung analysis nito, projectile, kung ito yung velocity, magkakaroon siya ng dalawang component dahil yun nga, naka-incline. So, yung vertical component, By, will be the velocity sine of theta. Yung Bx is the velocity cosine of theta. So, ano yung formula sa P6? Yung applicable dito, pwedeng yung final velocity, the base of 2 squared, equal to initial velocity squared, plus 2g h. So ngayon, ang gagawin lang naman natin is i-interpret natin siya in terms of yun nga, projectile. So ito yung parang by2 squared dahil vertical distance yung pinag-uusapan, vertical component ng velocity yung gagamitin. So by2 squared equal to by1 squared plus 2 times g times y. Y na lang yung gamitin ko. Pagdating sa highest point ng isang projectile, at the highest point, take note that the vertical component of the velocity is now equal to 0. Kapag projectile. So this will be 0. So mag-substitute na tayo. That will be 0 equal to by1. Ano yung vertical component ng velocity? That is 8.859. Vertical component, gamit tayo ng sine. So, by is equal to b sine theta. So, the sine of, the inclination is 45 degrees. This is 45 degrees, quantity squared, plus, yung sign convention ko sa g kapag pataas, this is negative. Kapag pababa naman, i-assume ko siya na positive. Pero sa akin lang yon. So, sa ibang reference, hindi ganun yung ginagawa. So, plus 2 times negative 9.81, y maximum. Kapag 0 yung velocity at the second point or at the highest point, that is y max. So, ano yung magiging maximum height ng jet of water above the orifice, sabi naman niya. But that will be 8.859, the sine of 45 degrees. That will be squared divided by twice of the 9.81. 2.00 something. So, sabihin na lang natin, this is 2 meters. So, question number 10 ito. So, check natin if we have that sa choices sa number 10. Doon tayo sa letter D. That will be 2 meters. Number 11, determine the time it takes for the water particle to reach the ground. That is 1.2 meters below the bottom of the tank. So, di ba yung total height daw ng tubig is 6.7. Kung yung head above the orifice is 4 meters, yung natitirang distance dito is 6.7 minus 4. This is 2.7. So, yung distance ng orifice, papunta dito sa ground will be, that is 2.7 plus 1.2. 2.7 plus 1.2, that will be equal to 3.9 meters. I-assign ko na lang siya as y. Y equal to 3.9 meters. So, ang tanong, gaano raw katagal bago marating ng tubig yung ground? Okay, pwede natin gamitin dito yung isang formula sa P6 ulit. Yun yung third equation. S equal to the B1T plus 1/2 of the GT squared. Yan. So, kaya lang dito, interpret lang natin siya as instead of S, that is Y. Dahil vertical distance ang usapan, gagamitin natin yung vertical component ng velocity. Ito yung actual velocity, sine up, theta. Okay, yung vertical component. Okay, take note ha. Ganun lang naman ng projectile. Kapag vertical distance ang usapan, vertical component ng velocity yung gamitin. Kapag horizontal, horizontal component. This is, yun lang yung B1. Okay, ito yung B1 times the time plus ay 1/2 gt squared. Again, yung g natin, ang initial direction kasi ng tubig is upward, that will be negative. Then, one thing more, kung babagsak yung isang projectile sa mas mababang elevation, ina-assign natin yung sign ng y as negative. So, dapat ito, yung y should be negative. So, negative 3.9 equal to vertical distance ang usapan, so gamitin natin vertical component ng velocity. 8.859 vertical component sine ng 45 degrees. Okay, multiplied by the time, okay, plus 1/2. Initial direction ng projectile ay upward, kaya ito ay negative. 9.81 times the time squared. Kunin natin yung time bago marating ng tubig yung ground. Negative 3.9 is equal to vertical component ng velocity, 8.859 sine up 45 degrees. Multiplied by alpha x, yun yung time. Plus 1/2, 0.5 times negative 9.81 times the time squared. So alpha x squared. So shift solve. 1.735 seconds. 1.735 seconds. So check natin if we have this value. By the way, this is question number 11. 1.735 seconds. That will be letter C na tayo. 1.74. Number 12. Compute the horizontal distance on the ground traveled by the jet of water from the center of the orifice. So, mula dito sa center of the orifice, papunta dito sa kanyang final point. Sabihin natin x. Or basically, ito yung range. Di ba may formula din tayo dito sa physics? For projectile na ganito yung case. Ito yung y is equal to the x. Tangent of theta ay minus the gx squared divided by twice actual velocity squared o cosine squared of theta. So, yung theta natin is, ayun nga, the 45 degrees. So, more likely, direct sub lang tayo dito. So, again, yung y natin should be negative dahil bumagsak siya sa mas mababang elevation. This is negative 3.9 is equal to 3.9 is equal to x. The tangent of 45 degrees, but I think this is 1, minus the 9.81 of x squared divided by twice. Actual velocity is 8.859 squared. Then, multiplied by the cosine of 45 degrees. Naka-squared din dapat ito. Yan, cosine squared theta. So, squared. So, solve natin. This is negative 3.9 is equal to, let's say this is alpha x. The tangent of 45 degrees ay minus 9.81 of alpha x squared. This is divided by twice. Actual velocity is 8.859 squared. Angle, cosine of 45 degrees squared. So shift solve. Take note na yung equation na to ay naka-squared, second degree. So there are two possible values of x. So tingnan natin kung kapanipaniwala, negative 2.87. Hindi pwede yan. So pwede natin gawin is shift solve bago tayo mag-equals. Yun lang, nawala yung equation. Ulitin lang natin. Negative 3.9 is equal to alpha x tangent of 45 degrees, minus 9.81, alpha x squared divided by twice of 8.859, squared, cosine of 45 degrees squared. So, shift solved. Okay, tingnan muna natin kung ano yung mga values sa choices. Okay, so nasa positive values lahat yan, kaya hindi pwede yung negative answer kanina. Pwede kayong mag-assume ng any value na malapit sa choices. So let's say 15, yun, average ng mga nasa choices para positive yung i-iterate ng calculator. Okay, that will be 10.87. So sa choices natin, that will be letter A. So minsan ganun kasi kapag yung degree ng equation mo ay second degree, there are two possible values. Kaya pwede niyang ibigay yung isa to satisfy the equation. 10.87 meters. That is the range of the jet of water from this orifice. So solution natin for number 10 to 12.